A little bit of an update on this Quincy compressor. I got some more parts today. Got some new belts I ordered from a company called V-Belt Supply, and I got the notched ones here. And I got a half-inch water separator, Norgren, eBay, brand new, 38 bucks. And then I got some Quincy parts here. Here is the new gasket for the inspection plate cover, and I don't know how well you can see that, but this cover is actually warped, so I'm going to attempt to hammer that flat and then use this new gasket and maybe put a little silicone on there. And then the other thing is the rear seal leaks on the compressor. It's you can't see it too well there you can kind of see it. But anyways, as you can see, this whole compressor is just covered in oil. And talking to Rotary Comtech, it sounds like it could very well be the rear seal. So I'm going to replace the rear seal. And this is something I was not aware of. When I ordered this, this actually comes as a whole assembled kit ready to go. So this is the latest and greatest. I was surprised to find out it came with the plate and everything, but it's already set to go. So I'll install this hopefully this weekend and get the new gasket on. And while I'm actually in the compressor, I'm going to flush out the inside of the crankcase and put some fresh oil in it. So, and then I also got the magnetic starter today. Mounted it, got some channel struts here, just bolted it to the tank, then to the back. And there's about an inch between the motor and the compressor. I hope that's enough. The only part that sucks about mounting it there is if that motor ever burns out. Most of the newer ones now are a little bit narrower but longer. So I might have to relocate the contactor or the magnetic starter again. So, and that, here it is. It's a Siemens. Got this from Surplus Center. It has an overload heater. I just haven't installed the heater yet, but the heater goes right here. I think it's good for 25.4 amps, so that should be good. The motor's good for 23 with a 1.0 service packer, so once again it's only good for 23. So, and the last thing I did, put that down here, is I replaced the motor pulley with a 6.75. So anyways, I figured this pump to be spinning at about 707 RPMs, and the way I calculated that is the flywheel is 16 inches in diameter, and from all the specifications I've seen on B section pulleys, it's approximately minus 0.35 from the outside diameter. So in this case here, it's about 15.65 is the pitch, and the pitch on the B section there is 6.4. So if you take the motor RPM, which is 1730, times the pitch diameter, it's 6.4, you come up with a weird number. Then you take that number and divide it by the pitch of the flywheel, which is like 15.65, and I think it came out with like 707 RPMs if I'm not mistaken. It's around 700, so I'm not 100% for sure exactly. And the beauty of it is when this gauge gets up to 150 pounds, I'm still only at about not quite 23 amps. So I don't have the amp meter turned on, but I'm going to fire it up just so you can actually hear it run with a little bigger pulley compared to last time. Here, whoops. Here we go. And I also got a new style air cleaner for air filters. A little bit of concern here is that this is vibrates. It's got a fine vibration to it, so I might actually drop it down to the next hole. But yeah, by changing to this style air intake filter compared to this old one here, which I guess is like a dinosaur. I don't know if this is original yet or not, but I was told that this style filter wasn't available anymore. So I got the new style, and this is the new style here, and it's really nothing to it. It's just the automotive style filter between two caps, and it pulls the air through here, obviously. So anyways, that's an update for now. I hope to get this magnetic starter wired to the motor, and I'm going to use the existing pressure switch. I did discover that that goes from 95 to 125, so that's right in my range. So, and I've got an air leak someplace still, because right now, if I were to bleed this off to 150, by the time I come in the morning or 24 hours later, I'm down to about 120 or a little bit less. And it could be this bleed off, or the unloading tower here, because as I was told by I think it was Rotary Comtech talked about in his rebuilding of his 325, that if you have a bad high pressure discharge valve, it'll actually leak here a little bit. And it isn't bad though. I mean, it's just ever so slightly. I'll hold my finger there for a few seconds. Yeah, I mean, it's just ever so slightly, and I can't imagine at that pace that dropped 30 pounds in 24 hours. So I'm going to go through and check all the fittings, and for all I know, it could be this really horrible valve here, or it could be leaking here. And I am also doing away with this tank drain. There is a plug on the bottom, and I bought a couple fittings tonight, a 12-inch long threaded pipe, and the ball valve. I'll put that in there for the time being. I am looking into an electric tank drain, and I did find one for 220 volt single phase, and my plans are I want to tie that in with the contactor, because the way these electronic tank drains work is they typically have a purge cycle of, I think, 0.5 to 10 seconds, and then you can set them up to purge up to every 45 minutes. You can have a purge for every 5 minutes or every 45 minutes or somewhere in between. And I see that very useless, because the only time I feel you really need to purge this is when you're actually using the compressor. So therefore, when I go home at night, I don't need this thing purging and then maybe triggering the compressor overnight, because it's purged that many times and lost that much air. So the idea is to tie the electronic tank drain, 220 volt electronic tank drain, into the contactor on the bottom side. So the only time the tank drain will get energy or electricity is when the contactor is closed and the motor is running. So, and I found one at Granger for $105 or $106 for a 1/2 inch. So the only thing it doesn't come with is a strainer, and if I want to order just a standard plumbing strainer for that, a Y strainer they call it, it's about another $20. So well, actually my cost on the electronic tank drain is about $92, and then I suppose that strainer is probably about about 18, 19. So I'll still have about $120 for electronic tank drain, but I believe it's well worth it. So anyways, that's the update for now. I will keep you posted as this project nears towards the end. Thanks for watching.